Okay, welcome to Graphing Systems of Inequalities, Part 2. I put a little example here, and you notice, first of all, when I say systems of inequalities, that simply means there's more than one. Okay, so here I've got two inequalities, and I'm going to solve by graphing. And the good news is there is no algebraic solving. I mean, because you're dealing with whole regions here and shaded zones, the only way you can do it is by creating a picture. So that's what I'm going to do. And in order to do that, what I want to do is take each of these, and they're slightly different. So I'm going to show you a bit of a strategy, and it really doesn't matter which strategy you use, a variety of techniques to produce the graph. So what I'm going to do, I'm going to clear the screen here, and I'm going to rewrite these inequalities over on the side, but first I'm going to paste up the grid here so I can see where I'm working. And here's what I want to do. I want to graph the first one, which is 3x minus 2y, and that says greater than 6. Okay. Now for this one, often it's easiest when they're presented in this form to just go ahead and work with this form rather than to rearrange it into slope-intercept form. So what I'm going to do is I'm going to get a couple of really nice easy points to produce the picture. And the easy points would be something like if x is 0, you put a 0 in here for x, and that's going to turn the whole first term into 0. And in order to make minus 2 times y equal 6, I got to have minus 2 times minus 3, and then it equals positive 6. I'm going to do the same trick by putting in a 0 for y. Now that's going to wipe out the second term, and I simply have 3x, and I want to make that equal to 6. So I think I want x to be 2. So in order to graph this line here, I would go 0 and negative 3, so 1, 2, 3. Okay, so there it is, and then I got 2, 0. Now this line, I'm trying to draw it pretty neatly here, but it's going to be, actually I better put in some more little dots here so I can see where I'm going. So I'm going up 3 and over 2 each time. And what I'm going to do is I'm going to connect all these guys with dotted line. Okay, so let's see what we can do here. Hopefully it looks like a line. All right, so far so good. Okay, I think we're making it. Okay, just about there. And put some arrows on this, and I think we are there. Okay, so I think in this case I use the table of values approach just because of the way this inequality happened to be set up. Now, to know which way to shade, I need a test point. So what could I use? Well, 0, 0 is always, for me, unless my line goes through 0, 0, it's kind of my first choice. So if I put 0 in for x and 0 in for y, I'm going to get 0 greater than 6. So what do you think? Does that look true? 0 greater than 6? I think that's false. And what does that tell me? Well, if this is where that point came from and that was false, then the true zone is over on the other side of the line. So I'm just going to mark that with some little arrows, and you'll see why I'm not making a great big shaded mess over there in a moment. Well, okay, that moment has come. What I'm doing is I got to leave my grid somewhat reasonable because I still got another inequality to graph right over top, and that's this guy. Y is less than or equal to negative 2x plus 3. Okay, now this one is in slope-intercept form, so the easiest way for me to graph this one is to realize my y-intercept is positive 3, so 1, 2, 3. There's my y-intercept, and my slope is negative 2 over 1. So that means down 2 and over 1. Okay, think of dropping negative 2, right? You drop 2 and 1 over. So drop 2 and 1 over, and so on. And I'm just going to mark this with a few points so I can get a reasonably accurate picture. Throw a couple of points this way. Now I'm going to use this little line draw feature here and see if I can do a reasonable line. And the nice thing is this line is solid anyway. So there it is. What a graph that is. All right, and I'm going to use a little strategy. Instead of a test point, I'm going to use the idea that the shaded part, so this is the shaded part, I want it to be less than or equal to the line. So if it's less than, that means I want it to be below the line. Okay, so I'm going to show that with some little arrows here. Now, here's the scoop. Because we got two inequalities on the grid, we're trying to show the true zone that works in both inequalities. Okay, so if I look at this line here, the solid one, I want only the points that are below that line. And if I look at my dotted line, I want only points that are below that line. Now if you look at it, that means you only want these guys here. Okay, so I'm going to shade this very carefully so as to not go outside of those lines. And why is that? Well, let me show you. If you were outside the line, say you were, well, I don't know, let's say you were, let's just finish this here. Okay, there we go. If you were, say, over here, okay, then that would be true for the dotted line, because you're below the dotted line, but you're above the solid line, so that would not be acceptable. If you were up in this region here, well, that's even worse because you're not below the dotted line, you're not below the solid line. And if you're in this region over here, say like this guy, that's great for the solid line, you're below, but you're not below the dotted line. So only these points are below both lines. And that happens to be where the true zone is for both of our inequalities. So that's what we've done. We've shown that zone, which is true for both inequalities. And theoretically, there's no reason you couldn't have a third inequality or a fourth. And the zone that's true for all of them is ultimately your solution zone. Okay? So that's how this works. And that means I'm done with graphing linear inequalities.